afternoon to all the participants and other faculty members in the different centers. There are 8 centers, 9 centers. Nice meeting you all. I'm sorry that I could not come for the inaugural meeting of this program, because I am coordinating another training program and I had to be there during that time. So I'm sorry about it. And I also thought that I will meet you in the afternoon session for the lecture. So it has been assigned to me to speak on soft computing techniques in research. So we will see what soft computing is, what are the various techniques in it, and there are various techniques in it, and out of all we will discuss neural network, artificial neural network, fuzzy logic, and little bit of genetic algorithm. And I will tell you what are the avenues or what are the research areas in electrical engineering in which these techniques are used. You will have a detailed lecture on electrical engineering areas, research areas in electrical engineering by Dr. Chatterjee, I think tomorrow only. So he will give you the detailed avenues and detailed areas. I will give you some, but mainly these techniques which I am going to discuss today are to be mainly used for your research work. So it will be easy for you to get an overview. Within 2 hours or 1.5 hours which Madam Poonam had given me, I don't know whether I'll be able to teach you all those techniques, networks and fuzzy logic techniques, but I'll give you an overview, and from that you can attend any of my course which I have to which you can attend in contact mode or in ICT mode, so that you can learn more in detail how you use all these techniques. Okay, so we'll go to what is soft computing. When we talk about soft computing, there we can say that there is something called hard computing also, which we usually use by using computer programs and other things. So it is here in soft computing, it is tolerant of imprecision, uncertainty, partial truth and approximation. Many a time, you know, in any computer programs or in when you write programs, you should give correct input so that you get correct output. Here, whenever there is less truth, imprecision, approximation, then soft computing is helpful. So the main techniques which we call as soft computing are fuzzy logic, neural networks, evolutionary computation, machine learning, probabilistic reasoning. All these are some of the techniques which we use in soft computing. The guiding principle of soft computing is to exploit, which I have told you in the previous slide, exploit these areas, uncertainty, partial truth, robustness, so that we, you know, human thinking is always like that, so that we can have that idea of artificial intelligence into it. So mainly these are neural networks, fuzzy logic, genetic algorithm and other techniques, and also a hybridization of these techniques. See, you have neuro-fuzzy, fuzzy neuro or neuro-GA. So there are various hybrid techniques in which we combine the utility of both of these also. Okay. So nowadays we use these in air conditioners, washing machines, camcorders, in so many industrial applications also. Such systems are becoming increasingly visible. I have been discussing this only. I'll be giving you more detail. Unique property, the soft computing techniques, the main property is it learns from the experimental data. You have some data, and from that data we can train a network, or the network learns, the program learns and then behave accordingly. So they derive their power of generalization from approximating or interpolating to produce outputs from previously unseen inputs. And this generalization can also be done in a high dimensional space. So we will go into these details. So I told you these are some of the techniques. So I will be covering neural networks, fuzzy logic and genetic algorithm, but not support vector machines, because in a small area time span I will not be able to finish all this. So first we will see into neural networks. When we talk about neural network, the main idea which comes into our mind is our brain only. So we have a biological neural network within us, with us. And when we think of the characteristics of human brain which we want to emulate or think of, then we see that these are ability to learn from experience, to generalize the knowledge, to perform abstraction. So these are what we have been telling you in the previous slides also. Imprecision, partial truth, generalization, learn from experience. All these capabilities are there in our brain. So let us see some of the constituents of the brain, and then we will go into an artificial neural network. In a human brain, there are over 100 billion neurons, and these neurons are connected by over 100 trillion connections. So these neurons are responsible for thought, emotion, and all our feelings. And also these are also required for our learning. That is what the word cognition means. We learn by means of these neurons only. This is a simple picture how this network is an expanded view of a neural network. This is a picture of a neuron. See, it is a tail-like structure. This is an expanded view of a neuron which has various tail-like structures. I'll explain what these are, and all these are many inputs and one output unit. A neuron has all these tails carry information into it, and one of it carries the output. So what are these? So if this picture will show that there are many input tails, that those tail-like structures which carry the signals in are known as dendrites. See here, this is a dendrite. These are all dendrites, and whereas one of it is an axon which carry the signals away, and this is the cell body and a nucleus is there. And so this is a fundamental picture of a neuron, which is the cell of a human brain. Other cells of the human brain are not called neurons. They are simple animal cells. But the brain cells are known as neurons. This is a picture of a dendrite which connects to an axon. See, this is a connection of a axon to a dendrite. There is no physical connection. So one axon will connect to a dendrite and the information will pass on. So this connecting structure is known as a synapse. This connecting structure is known as a synapse. So this area where these neural molecules, neurotransmitter molecules, transfer into the dendrite. So the information pass on from the axon to the dendrite or from the dendrite to the axon by means of these neurotransmitter molecules. This is axons. Axons can be as short as 0.1 millimeter to 1 meter in length. They are connected by means of Schwann cells and nodes of Ranvier. I'm not going into the details of all this. Now let us see. We have seen each of the neuron has input structures and output structures which carry signals in and carry signals out, and it has a cell body which will have all these molecules also in it. So now let us see what are the how can we compare a computer to a human brain. Similarities, when we count, it is both operate on electrical signals, both are a composition of a large number of simple elements, and both perform functions that are computational. Okay, when I talk about electrical signals, I did not go into the details of all this. Each of the neuron cell body is in an equilibrium when it is not doing anything. As soon as it has to pass on some information, it passes on the information in terms of electrical charges. They say that a 70 millimole plus 550, 120 millivolt potential travels from one neuron to another neuron. So it operates on electrical signals. This is the reason why we could measure EMG or EEG or ECG because of these electrical potential which travel from one part of our body to other part of the body or from within the brain. Similarly, there are some differences. Compared to microseconds or nanosecond time scales of digital computation, nerve impulses are very slow. Our machine will work on nanosecond or microsecond time, but our human brain do not work like that. Okay, and the brain's huge computation rate is achieved by a tremendous number of parallel computational units. I told you there are over 100 billion neurons, and all these are connected together by having around 100 trillion connections. So that much connection cannot be proposed for a computer system. Next is, a digital computer is inherently error-free. We cannot always say that a right input will give you the right output. But brain is not like that. Brain often produces best guesses, approximations from partially incomplete and incorrect input. So that first slide I told you, it takes into consideration the partial truths. Our brain can work on approximations, on best guesses. Okay, so that capability is not in a digital computer. So our main aim is to impart or inculcate that capability into our machine so that it becomes intelligent, or we call it as an artificial intelligent system. See, if I take a simple neuron like this, I told you it is a many input, one output unit. So if imagine it has inputs like I1, I2, I3, In and one output S. What is it doing with these inputs? That's what we are going to see. Each of the input is associated with a weight. So I1 is associated with a weight W1, I2 with W2, I3 with W3, In with Wn. And these I's and W's, inputs and weights, are multiplied and added. See, X is equal to, first line, therefore X is equal to I1W1 plus I2W2 plus all INWN. That output X is then applied to an activation function. We call here, it is known as a threshold function. And if a threshold value X T, so we compare X to that T value, X is greater than T. So S will be 1 or S will be 0. So the threshold value is T. If X is greater than T, then the output will be 1. If not, it will be 0. So that T is the threshold value. But it is not that every time any neural network will take a decision having a threshold value, and if it is more than that, it is 1, and it is less than 0. No, in some cases it can be a gradual transition. So when we require a gradual transition, activation functions like this also can be applied. See here, there is a gradual transition from 0 to 1. See the blue curve over there. You have values between 0 and 1, 0.1, 0.2, 0.5, 0.8. So to get such values, we can use mathematical equations like 1 by 1 plus e raised to minus ax. See here. So what is x? X is the calculated value here, I1 W1 plus I2 W2. Okay. So you have A, depending on A. See here, when see the blue curve and the black curve. The black curve has a fast transition. There are not much values between 0 and 1. But in the blue curve, there are values. That means it has to be multiplied by some values of A. A is equal to 1 by 3 or A is equal to 1 by 2, so that X value becomes a smaller value, so that the transition becomes slower. Okay. This is also another logistic function or squashed function, squashing function or sigmoid function. We call this you read this in different names in different literature. Similarly, this is also a sigmoid function, which is known as a hyperbolic tangent function. Here also it is almost similar to the sigmoid function which we have seen before. The only difference is that here the transition is from -1 to 1. The transition is from -1 to 1, whereas in the previous case the transition was from 0 to 1. Here also you can multiply X with values of A, so that you can make this transition slower or faster. See, we have seen one neuron. Many a time our industrial applications or the application where we use is not a one output system, many input and a one output system. We require more outputs. So when we require more than one output, we have to use more than one neurons. See the figure here. Number of inputs can be restricted. You can have 5 inputs and 2 outputs or 3 outputs. So 5 inputs we can have because the neurons have many input, but output it has only 1. So here what we have to do is we use a number of neurons. So when I have a 3 output system, as in this picture, we can use 3 neurons. Number of inputs can be fixed accordingly. So when we have more than 1 neurons, we have different type of network architectures. So this architecture where you have only one layer of neuron, even though there are number of neurons, but then the layer is only one. So we call this as a single layer neural network. Single layer neural network. Whereas here it is different. Here we have multi-layer neural network. See, we have multi-layer neural network. In such cases, many a time what you see this example. You have inputs like light, temperature, humidity, carbon dioxide, nutrient, age, plant type, and then various outputs like transpiration, assimilation, allocation. Do you think that we can get values by simply multiplying I1, I2, I3 with some W1 and applying some activation function? May not be. So what you have to do, you may require more than one hidden neurons in between, so that you get an output, you get outputs similar or comparatively to the inputs. So you may have to do the calculations again and again. So you may require multi-layer artificial neural network. This is one simple picture of a multi-layer which has only one hidden layer, one layer of neurons as the hidden layer. There can be n number of hidden layers in between the input layer and the output layer. See here, this is also a multi-layer network. Main characteristics of a multi-layer is that it is a feed-forward network. Here the network architecture is feed-forward. What do you mean by feed-forward? Output to the first layer is given as the input to the second layer. Okay, so output to the first layer is obtained by multiplying the input vector by the first weight matrix. So we get the output to the first layer, and then the output will be given to the next layer as input. Then again a second set of weight matrix will be multiplied with that and will be given to the next layer. So if you have 3 hidden layers, the output from each layer will be given as the input to the next layer. Okay, and in each layer you have a weight matrix and you have a nonlinear activation functions, so that you get the output. Another main consideration in networks, network architectures, whatever be the architecture, it can be single layer, it can be multi-layer, it can be feed forward, it can be feedback. There are various types of network architectures which researchers have found out and people have been using it extensively. So you can read any book on neural network or go into various literature also to find out the different types of networks. I'm not going into all the details of the networks in this small class. I will not be able to. But the concept is, one main concept is the training. See, training is accomplished by sequentially applying the input vectors and adjusting the network weights according to some predetermined procedures. Now what do you know the input vector? And we have a set of network weights which we start as the initial weights. And then during the training, we have a predetermined procedure of changing the network weights, changing the network weight. That procedure of changing the network weight is known as training. So the main characteristics of main types of training are the supervised training and the unsupervised training. Now when we talk about supervised training, means you have a target value. The network output target value is given. And with that target value, every time we compare the calculated output of the network, every time we compare the calculated output of the network with the target output, and the error, that means t minus y, t is the target, y is the calculated value, t minus y is the delta. That t minus y will be found out and the weight will be changed accordingly. In some cases it is proportional to w, error itself we will change. We simply multiply it and add it to the weights. So it always, the weights are always changed with respect to the error. The error means the error value difference between the target and the output. But in unsupervised training, there is no target vector. There is no target vector. Now, how will it modify? There are algorithms. The training algorithm modifies the network weights by comparing it with the output of the previous iteration. So the output of the previous iteration and the output of the present iteration is found out, and the difference between these two. So the error between these two will be taken to change the weights. That is how we do in unsupervised training. In unsupervised training, there is one more type of training which we call as a competitive training or winner-take-all training. In that, we find a particular characteristic vector or characteristic point which it requires will be calculated, and one of the neuron will be getting the highest value, and the weight of that vector, that neuron will only be changed. So it is like a competition. Only all the neurons will participate in the calculation. All the neurons will participate, will calculate the value. And then there is a comparison of all those values, and only one value will be considered, and the neuron which has that value will be allowed to change the weight. Only that pair of weight only will be changed. So it is known as a winner take all or a competitive mode of training. Now this is a basic model of a neuron, which we call, it can be the neural network which I have shown you in the previous, which has inputs and one output. It is known as a perceptron input, simple values. You go to papers, it will be called as a perceptron network. It will always have a hard limit threshold function, and it will have only one output. In cases where you require more than one output, you can have a single layer perceptron network also. Okay. So now let us go into the details of it. Here the inputs are defined as x1, x2, xn. Weights are w1, w2. There is a bias value also added to it. I'll explain what it is. And then the output which is calculated at this point, will be given to the activation function, and this is the final output which we get. Now let's go into the details of this. This network is developed by Frank Rosenblatt, and the learning algorithm, I told you the supervised learning algorithm is that the weights are adjusted to minimize error whenever the computed output does not match the target output. So net is calculated sigma xi wij. Sigma xi wij means x1 w1 plus x2 w2 plus x3 w3 plus xn w1. That's the meaning of that. So you will get net, and that net is applied to a activation function. What is that activation function? If net is greater than 0, y will be 1, otherwise y will be 0. So imagine you have a target output and a particular y value is also calculated. So now how will you change the weight? That is what we have to see as the learning algorithm. See, if the output is 1 but should have been 0, that means the target value is 0 and the calculated output is 1, then the weight will be changed. See how the weight is changed. Wij is the present weight minus alpha xi. Alpha is known as the learning rate, xi is the input. And we get the new weight. If otherwise kya hai? If the output is 0 and the target is 1, then we add it. If the output is 1 and the target is 0, then we subtract it. So there is a plus minus ki difference, weight adjustment. But then that is a very coarse type of where you have only 0 and 1 values. Where you have only 0 and 1 value, only you can use this method. If there are different than 0 and 1, 1 and minus 1, if the output values are minus 1 or 1, or real valued values, if the inputs are in the example which I have given, the inputs are also binary, the outputs are also binary. But here it can be in binary, bipolar or real valued inputs. Real valued means you can have 2.3, 4.2. ऐसे भी values आप use कर सकता है. And the output values are always bipolar. Then what we do, we use a delta rule. What is the delta rule? We take the difference between t and y. See here, t minus y is calculated. This is the error. That is then multiplied by input xi and multiplied by the learning rate and added to the present weight to get the future weight. Okay, so this method is known as a delta rule. In these cases, when output values are bipolar, t minus y means minus 1, you may get minus 2, or 1 minus minus 1, you may get 2. So t minus y can be minus 2 or 2. Whereas this is the same case which we use here also. Here t minus y can be minus 1 or 1. That is why that minus and plus sign over there. You should understand this. This is the same delta rule ही हम इधर apply कर रहे हैं. But here, because the output is 1 and 0, we will get t minus y as plus 1 or minus 1. So we can easily use plus sign and minus sign. Then another network is the back propagation network. Back propagation network is a very commonly used network and very high, built on high mathematical foundation and with very good application potential. You read papers, you will find it. In some books they write it as multi-layer feed forward network, MLFFN, or they write it as back propagation network, BPN. In some papers you will find it as EBP, error back propagation. All these are same. Multi-layer MLFFN are networks where back propagation is applied. So that is why I'm saying some papers they will call it as a back propagation network, some they call it as an MLFF, multi-layer, whereas it is applied to a feed forward network. So see here, there can be different, so in that cases you use a gradient descent learning algorithm. In gradient descent learning algorithm, the error which you calculate t minus y, the error which you calculate t minus y will be differentiated del E by del y or v or del w. So it will be differentiated with respect to the weight matrix, and that value will be added to the present weights. So here that is why it is known as a gradient descent. In the previous case, the error as such was multiplied. Error as such was multiplied. So it is like a proportional change. When you, I am not taking much of numericals here. If any one of you are interested in learning more about it, you can attend any of my training programs which will come in this year. The new year has started, our academic year. I don't remember the days. You can see the training program through our network, operational plan network. Usually I do a 1 week training program fully on neural network, fuzzy logic and genetic algorithm, so that you can attend it on contact mode. Come to NITR so that we will make you do various application problems so that you will learn more about it. So I encourage you to attend some contact programs here on this area if any one of you are interested to do their PhD or ME thesis using these techniques. Okay, so here within 2 hours I will not be able to give you all the numerical methods of how to do it, how to calculate the dE by dW and then add or subtract depending on the sign change over there, so that the weight matrix will be changed. So it is an iterative procedure. You have to do it again and again and again. The network will do these procedures again and again during the training process. Okay, during the training process it is an iterative procedure, and it will learn from, well, that is why we are saying it will learn from the experience what it does again and again and again, and it comes to a particular final weight which will act as if you give the inputs and you get the output, because target output is already given. So the calculated output has to match to the target output. Till then we do the training. So when the target output is matching with the calculated output and the weight has been changed till then that particular weight will be used as the final weights for the network to behave in a particular way in that problem. So whatever be our problem, whatever be our inputs, and the target output is known, means we will be able to find out the change in the neural, in the weights. Okay, and the final weight will be calculated. Now this is I'll give you the names of only 2 networks. I'll go into fuzzy logic afterwards. These are also different types of networks. I told you in perceptron network, we usually use perceptron network for classification problems. The back propagation network we use for control problems, engineering control problems. HOPFIELD network is used to it is a feedback network. The output is fed back to the input. So that is why it is known as a single layer recurrent network. In this, it will not be multiple layers, multi-layers. It will have a input in similar ways. Mainly these are used for associative memories also. We call it as we can remember the things. So we call it as Hopfield associative memories or auto associative memories. Like you train it for a particular application. Like you train it for remembering the alphabet A or reading the alphabet A. So as you know, different people write A in a different way. Imagine you have trained it for 200 different types of A's. Then when you show an A to it, it will read it out to be an A. But in the other case, which I have written here as the bidirectional associative memory, it is a two-layer heteroassociative network. Here it can store pattern pairs. So there are two sets, x1, x2, x3, x4, where x1 is associated to y1, x2 is associated to y2, x3 is associated to y3. So there are pattern pairs. So when x1 is input, it has to give y1. It has to give y1 as the output. Got it? So it cannot be done in a single layer network. There should be a two-layer network, and it is known as a heteroassociative memory. So here the weights are not trained. The weights are calculated from the values. We don't take weights as assumed values. Here weights will be calculated, and using those values, we will see whether the input, when it is given to the weight matrix, whether it will give you the output. If it does not give the output, we will again iterate it by making small changes so that it will give you the output. So here it is, these two networks, Hopfield network and BAM, bidirectional associative memories, are, from the name itself you can say, they act like a memory. They remember things so that you will get the output from the input. So to remember it, we have a particular set of network, particular weight matrix, which is calculated by means of the inputs which we supply. Okay. Now we'll go to the next area, which we call as fuzzy logic. See here, as we use the word logic, you all remember the word binary logic or Boolean numbers. When we talk about logic itself, we remember those binary numbers 0 and 1. But in fuzzy logic, it is a multi-valued logic. And the multi-valued logic means there are values between 0 and 1. There are values between 0 and 1. So we will see how it is done. It is initiated by Lofty Sadeh, Professor Computer Science, University of California, Berkeley in 1965. One more line I have written there is based on natural language. We will see how is it. It is conceptually very easy to understand, flexible, tolerant of imprecise data, nonlinear functions of arbitrary complexity can be modeled here. Okay, usually you know it is very difficult for modeling nonlinearity. We assume any nonlinearity to be linear to model it. That is what we do, or else we have to go for higher order partial differential equations. So when we see all those things, fuzzy logic is a very easy technique which we can do for our research purposes. In research purposes, the main activity which we do every time is the modeling. And that too modeling nonlinearity. Okay, so here it is very easy to do that modeling part of it. How will we do? You may ask, how can we do it? Because we make those non-linearity or the total characteristics of the system in if-then rules. That means we built it on top of the experience of the experts. See, a particular system will work in such and such a way. If the input is this and the input is this, or the input is this will be the output. So if you can write if-then statements based on the experience of the expert or you as an expert, then that can give you a very means that can give you results. So fuzzy logic is very much useful in such situations. So the expert has to translate your system into such a way. That's what we are going to see how we will do it. So before going into the logical concept of it, we will start with the concept of a fuzzy set. See, whenever we have already learnt of classical sets and Venn diagrams when we in school and in college. In schools itself we have learned it. See, for any classical set, it has a crisp, clear boundary. I think I have some pictures. Okay, crisp, clear boundary. So, but fuzzy set do not have a clear boundary. In any classical set, we can say that the member of the classical set is a member, and we can say that the membership value is 1. If it is not a member, the membership value is 0. But in a fuzzy set, there are membership values between 0 and 1. Between 0 and 1. That means there are partial membership functions, partial membership values. So a member can have a membership value 0.2 or 0.7 depending on its location in the set. Okay, so a classical set has clearly defined boundary, whereas a fuzzy set do not have a clearly defined boundary. So it can be a member, it cannot be a member, or it is like that it can have a partial membership value also. Now see here, a set of real numbers from 1 to 10 is the universe. And we took a set of numbers between 5 and 8, A. So if I draw a Venn diagram, you know we'll have a circle within a rectangle with 5, 6, 7 and 8 on the in A. And we say that 5 is a member and 2 is not a member. That is what I have shown in this graph here. This is known as a membership function. When I plot the membership value with respect to the member, here 0 to 10 are the members and the membership value is plotted. So 5, 6, 7, 8 have membership values 1 and 0 to 4 and 8 to 10 has values 0. You can see this. Now this is a fuzzy set. See, when I define a set of young people, and as you all know, it's very difficult to define the age of anyone. People usually do not disclose their ages. So to call a person old or young is very difficult, you know. Here also, so what happens here, we cannot define or call a person old as soon as his birthday is or after his 20th birthday. No. So here it is a fuzzy set. You know, human thinking is always fuzzy. If I ask you about the temperature today, you may give me different answers. You may be, so it's very hot, it's moderate, it's good. Depends from people to people. Depends from human to human. So we think in different ways. So we cannot define the word young. We cannot define the word old. So there can be members, there can be non-members, and there can be partial members also. See the table over there. I have written 65 as not a member of B, whereas 17 is a member of B, whereas 27, 22 and 25 are partial members. Partial members of 0.8 or 0.5 or 0.3. You can define it in a different way. You may define the age gap, which I have drawn it as 20 to 30, you can make it 20 to 50 also. Okay, or those who are elderly than 50. So it depends from person to person. The definition is always fussy. That is why we call it as a fuzzy set. It does not have a clear-cut boundary. Okay, that is the definition which I wanted to give you. Now, what all I have told you, I am again telling here. Membership function is a curve, and membership values are values between 0 and 1, and is often given as the designation mu. So mu AX is called the membership function of the member X in A. See here, the same figure. If I make a set A, which I call as a set of old people. Set of old people. So in that set, 65 will have a membership value 1. Okay. And 27 or 28 will have a partial membership, or 32 will have a partial membership. So it depends on what set you are defining. So X member can have a different membership value in A or in B. Okay. One more thing I wanted to tell you is the word called linguistic variable. See here, how I define, like, you know, I am defining a linguistic variable season with the seasons, spring, summer, fall, winter. Okay, so the season is the linguistic variable. Linguistic means related to language. See, I have shown you in a slide that fuzzy logic is based on natural language, based on how humans think, based on how human beings think. So here we call seasons spring, summer, fall, winter. We will not say that spring is from June to April to June, or we do not know where it will start. There is no clear boundary that on June 1 the summer will start. No. Summer, the starting and go of summer is a gradual process. So we do not have a clear-cut boundary. So these words like linguistic variable and linguistic terms are defined as per the natural language terms which the human beings use. The membership functions can also be different. See, there are triangular membership function, Gaussian, trapezoidal, generalized. What is the meaning of these membership functions? You see the triangular membership function. See, it shows that only one member has the highest membership value, and other members have membership value less than that person, that member's membership value. Whereas in a trapezoidal, more members have higher, same membership value, which is the highest value. And in Gaussian and Bell also there are different. Gaussian, there are more members nearby the membership value. So you can define the types of various types of membership functions. Okay. Now I'll take a simple example of a fuzzy control. See here, a simple example, because I have not gone into all those details of fuzzy set and fuzzy logic, but I'll come to the fuzzy control part of it. See, any control problem which you take, you know that it is like a black box. It has some inputs, it has a process, and it will give the output. So here you have some input values and you will get some output values. So any control problem which you consider have the input values in crisp form only. So what we do is those input and output values in the crisp form has to be converted to fuzzy values. Has to be converted into fuzzy values using membership functions, so that we can graphically describe the situation. See here, similar membership functions you can define. Here, the linguistic variable is temperature. The linguistic variable is temperature. So here, we define the temperature as cold, cool, nominal, warm, hot, just like human beings specify it. Told you, we will not specify that the temperature is, oh, temperature must be between 32 and 45. No, We usually say that it is warm, it is hot, it is very hot. So the linguistic terms in which human beings think, that is what we use here. So these are known as the linguistic terms, and the total variable is known as the linguistic variable. Similarly, your input can be speed, your input can be voltage, your input can be resistance, your output can be torque. Depending on your control problem, define the inputs and the outputs and specify it or define it in membership functions in the graphical form. So defining this in the membership function form is known as the fussification process. So for any inputs and outputs, you have to first do the fussification of it. Then you have to find out what are the rules by which the output is controlled by the input. So that rule definition is known as the rule definition, and then we call it as a rule evaluation. And after doing the rule evaluation, we get a fuzzy output, which has then to be converted to a crisp result value by using defussification. So this is found out by Ibrahim Mamdani, and Mamdani has found out various methods of defussification and rule evaluation, which we call as Mamdani's rule. Okay, I'm not gone into all the mathematical details of Mamdani's rule and all. As I told you, if any one of you is really interested in learning it, you can contact me or come to any of my training programs, because the time is very small, very short here. See here, I'm having an inverted pendulum example here, and here the problem is to balance a pole on a mobile platform. So the speed of the platform by which it is moving is the output. It has to be controlled so that the pole will stand on the platform. So the pole on the platform will try to fall. So the angle between the platform and the pendulum and the angular velocity by which the pole is falling down, ये हमारा inputs है, and the output is the speed of the platform. Now we are not modeling the inverted pendulum. That's what I'm going. We are not modeling the input pendulum. We are not writing any mathematical equations. What we are doing is, the first step is we do fussify it, write some rules how the output, the speed of the platform is related to the angle and the angular velocity, and then we evaluate those rules and find out the defussification. That's what I'm going to show you here. See, to make the fussification, as I told you, I have taken the output, inputs, angle and angular velocity, and defined it into its linguistic terms as negative, high, negative, low, zero, positive, low, positive, high. Similarly, I have taken for speed also. So all these various, it has been found out from the range of maximum speed, minimum speed to maximum speed has been taken, and it has been divided into a graphical form like this. So this is the fussification part of it. Once you fussify, then it is the rule statement. So the rules are written by using if-then statements. If angle is 0 and angular velocity is 0, then speed is also 0. If angle is 0 and angular velocity is negative low, then the speed shall be negative low. So it is simply on the experience of the experts. See, many a time I give the example of a washing machine. Fussy washing machines, एक time पे fussy washing machines, fussy rice cooking machines were all very popular. Nowadays it has become less. But then when you design a fussy washing machine, we are all experts as we design it as if we are all very experts in washing clothes. हमें कितने कपड़े धोना है, कितने बकेट पानी चाहिए, कितने सोप चाहिए, हमें we know it and we write rules accordingly. So एक कपड़े धोने का एक expert बन के if we can write rules, similar is the case for any problem you take. You as an expert, if you are as a designer is not an expert, you may have to go to the foreman and the supervisor who works on it in the floor situation. So you have to understand the actual characteristic working of it than mathematically modeling it. So once you think in a human way, that's why it is known as an expert system. Once you think it in a human way, like, and write rules, and any number of rules by which you may have to write 500 rules or 50 rules, the more number of rules you will be able to explain it more. And depending on these rules, you will be able to evaluate it. Now you see, you have written the rules. In some cases, as I told you, if it is in my cases, I have written only for 9 or 10 or 9 rules. But if you have 50 or 100 rules, it will be better if you write it as a table, so that it will be easy for you to understand what you have written. Okay, this is a tabular form of a rule evaluation. Now, how do you evaluate it? See, as you know, it is not that actual situation is not fuzzy. Actual situation is crisp only. You have crisp values of input and you will get crisp values of output. हमारे inverted pendulum के case में एक particular value of angle and angular velocity is required. So वो angle and angular velocity की values को लेके what value of speed are you going to get? So here, and see this picture. I have an actual angle value here. See, it is more than 0, greater than 0. This actual angle value is intersecting these fuzzy pictures. See here, 0 and positive low पे ये intersect कर रहा है, देखा? Similarly, this actual angle value is also, angular velocity value is also intersecting negative low and 0. So the rules which are associated with these will be evaluated. If angle is 0, angular velocity is 0, then speed is 0. If angle is 0, angular velocity is negative low, then speed is negative low. If angle is 0, angular velocity is positive low, then speed is, that is what we are going to see now. See, each of these rules, angle is 0, angular velocity is 0, speed is 0. They could see the value of membership value. See the membership value. 0 pay here. See, I think you can see the arrow which is moving. Here it is 0.75. Whereas here it is 0.25. So 0.4. So we take a comparison of this and take the minimum of it. Okay, so you may ask me why minimum. Mamdani has found out that it should be minimum. I have not gone on to the details of it. Mamdani takes it that the minimum will be the right. Uska reasons hai. So minimum we take. Similarly, we evaluate for all the rules which will be associated with the actual values of angle and angular velocity. And you will get a picture like this. Now when I combine all these falsified values, देखो आप negative low पे मेरे को 0.6 मिला, 0 पे मेरे को 0.25 मिला, previously 0 पे 0.4 मिला और positive low पे मेरे को 0.25 मिला. When I combine all this, I'll get a black figure, the black colored figure. That is the result, fuzzy output which I get. Now you may ask me, ma'am, ये fuzzy output से हम क्या करेंगे? ये picture से हम क्या करेंगे? Yes, this is the fuzzy output of speed. Now what is the crisp value? The crisp value to find out is you find out the centroid of this picture. ये जो नीचे जो picture है, अब देखो there is a red point over there and वो red point के corresponding speed, this red point is the centroid and the corresponding value is the speed, crisp value of speed. Now when I explained to you, you felt it very good. ये तो बहुत easy है. But when you start calculating the mathematical calculation, it is not that very easy. I make my ME students do a 2-hour problem, numericals on this, calculating the value of speed. But then MATLAB as a software has all these GUIs and toolboxes of fuzzy and neural network, by which you don't have to do the mathematical calculations of it. You can write programs or work on the GUI so that you will get the output of the fuzzy values. Okay. We'll have some time of questions. Let me go into the next techniques also. Then we will come to the questions of it. Next soft computing technique is the genetic algorithms. See, as the word genetic comes from a biological situation. I told you, our soft computing techniques are all dependent on the biological situations. Uska bhi reason hai, human thinking, human brain, or human genetic orders. So these all behave in a particular way. We can define some algorithms by means of this. In addition to, I am only considering genetic algorithm, which is the basics of this biologically inspired situations. There are various evolutionary algorithms have come up. You will be able to find out lots of techniques. Particle swarm optimization, ant colony optimization, honey bee situations, harmony, musical harmony search algorithms, so many situations, so many different types, frog jumping algorithms. So all these biological inspired situations can be converted into some algorithms which behave in a particular way. And on top of it, they say that these situations, it be an ant or a honeybee or a frog or a bird or a human gene, all will take the easiest path or the survivor of the fittest, or I told you competitive rule. So see, that's the first word I've used. Genetic algorithms are inspired by Darwin's theory of natural evolution. That means organisms that are purely suited for an environment will die off. We all see that throughout the ages of evolution. Many of the species are no more in the surface of Earth. They have died off. But the fitter ones survived it. So we go for a space of individuals which will survive, which is the best way of doing it. Okay, so chance of an individual being selected is proportional to the amount by which its fitness is greater or less. It can be in our condition. In which condition you work, it can be a greater, higher value or a lower value depending on the fitness. So it can be greater than or less than its competitor's fitness. So it depends on the problem which we take. So what we do, we have a set of initial solutions. So we have lots of values as a final, as an initial value. Here they call it as a chromosomes, and otherwise we call it as a population. Okay, now a chromosome is a string of elements. Chromosome means chote elements. They are known as the genes. Now solution from one population are taken and are used to form a new population by generating offsprings. So there we have a set of population. वो set of population से हमें next set of population बनना है, like we call it as a generation. See, we are all generations of a previous set of people, and we feel that we are far better than our grandfathers in terms of education, in terms of money, in terms of living situations. So we are better. And when we think of our next generations, they may be even better than us. So it is always a new population से एक old population से एक new population जब बनता है, it is based on their fitness value, and those who are not fit will die off, and we also will see what are the best ones. Okay, so there are methods of how to find it out. Okay, so we'll go into those details. Okay, now here we have a generation 0, we call it, create a population of chromosomes or whatever the problem we are looking into. Uski एक set of values आपको चाहिए पहले, we should have a population and we determine the fitness of that value. वो fitness calculation करने का कोई एक fitness function होगा. If it is a power system, we have an equation which defines it, by which we can find out the fitness function. Or for that matter, any control problem which you have, it will have an equation which describes it, so that we can find out the fitness. We can consider that as the fitness function. And using that fitness function, you will find out the fitness value of all those values. And then what you do, we select the best out of it. And these best now what we are going to do, we do a reproduction. Why we take the best of it? Because we say that if the parents are good, the children will always be good. So that the reproduction will give you a next set of the best results. Got my point? So out of all the population, I am not going to take all. I'll find the fit of all. Fitness values जिसका high है, उसी से crossover करके I find a reproduction another generation. वो generation में then I do again a technique. इसमें भी देखो एक father mother का 10 बच्चे हैं, उसमें भी I can see that 2 or 3 may be good, बाकी fit नहीं होगा. So we do a process called mutation again to find the best of all those 10 values or reproduced children values which you have got. Then again do the fitness of that. Again find the best. Again do the crossover. Again do the mutation. So that you do it again and again, as I have written 100 times iteration, so that you get the best result. Optimal value of it. Oh, hope you got it. So that process of iteration, that algorithm of doing it is what we call as genetic algorithm. Okay, let me go on to a little bit of details. This is how we make it as a program. देखो मैंने एक algorithm, जो मैंने एक flowchart बनाया था, उसके पहले I have explained it in words. Then I have made a flowchart of it. From the flowchart, we write an algorithm, and from this algorithm, you can go into a program. You write a detailed program in MATLAB, in C, or any language which is comfortable for you. Usually, we write in MATLAB, so that MATLAB will give you an efficient program in less number of lines. So here, start is generate a random population of n chromosomes. Many a time we have some experimental values. Okay, or some experimental values, and from those experimental values you create more values, multiply or add or do something. So you generate some problems, or you have a particular graph of that function, and from that function graph you generate the values. That's again another way of doing it. So you generate the random population. Then using a fitness equation, find the fittest of all that. So you write a program to find the fitness of all the values. Then select some of the fit values. So here, selection. So the selection also have various methods. You go into book and literature, there are various methods, Rowlett wheel, selection methods are there. And take kitne bhi parent chromosomes and then crossover it. I'll show you how crossover is done, and mutation. After the mutation, a new set of population is found out. वही population पे again you go to the fitness value. So that is again repeated until a condition. You give a condition which is the terminating condition. So we'll start from the termination point. How will you define the termination? reaching some fitness, that can be your termination. Some maximum allowed number of generations, you say I will do it for 100 generation and get a value, or some minimum level of diversity, or some specified without number of generations without fitness improvement. समझ में आ गया? Fitness becomes same. So you say that मैं इधर मेरा program को stop करूंगा. So termination of the loop has to be designed first. Okay, where should I require, till what I require this. मैं इसको 100 times iteration करूंगी, 2000 times iteration करूंगा, वो you should be knowing it. Now we'll see how we do it. Okay, okay, now do the fitness function. Represents the requirements that the population should adapt to. We have an objective function or a quality function depending on the problem in which you are applying it. So it is calculated first, decoding the chromosome and then evaluating the objective function. Okay, or the fitness function is an indicator of how close the chromosome is to the optimal solution. So it is up to the researcher to find out what is your fitness function. So now using the fitness function, you calculate the fitness values so that now you are not taking the whole population. You will reduce that population to some number of values. Okay. Now from those values, you select some parents from which you can calculate you can do the crossover. So depending on the fitness, that's the first method of doing it. You calculated the fitness, higher the fitness, or you calculated some value of the objective function, lower the value, depending on. Okay, high quality solutions more likely to become parents than low quality. But it is not that every time you take like that only, depending on your problem. Even the worst in the current population usually has non-zero probability. In such cases, तुम्हारा calculation में या कुछ तुमने जो equation लिया है, उसकी constraints लिया है, uncertainties लिया है, उसमें भी तुम्हें fitness value बहुत high मिलेगा, but the parent must be a weak fellow only. So that all those things also has to be considered. So you may not take completely. So you may have to use some probabilistic method so that you take the best parent. Okay. Now going to survivor selection. Now you will find this is another method, fitness based, that is rank parents and offspring, parents plus offspring and take the best. Or it is an age based. Okay. Sometimes it is a combination of two. Okay, so it depends on you. Go into books, you will find various methods of doing all this. Now the encoding. See, I told you, you have some problems. Yeah, crossover and mutation will be easy if you do it on a bit by bit method. So encoding your values into a binary string is the next point of it. Okay, so before crossover, you have to encode your information into a binary string. So here there are two parent chromosomes which I have selected as in the previous solutions. So these chromosomes are encoded into such a bit string. Okay, so each bit in the string represents the characteristics of the solution. You all know the bit number of bits increase होते ही value increase हो जाता है, you know that. So there are many other ways also. So here मैंने encoding, जो भी मैं encoding use किया हुआ, the chromosome is found out. And now we'll go on to the crossover of it. See, here this is the first chromosome 1 and chromosome 2 as in the previous slide. I have divided it into by using some value. एक dash line मैंने रखा हुआ, I divided it into two portions. So chromosome 1 को मैंने दो part में divide किया. Similarly chromosome 2 को भी मैंने दो point में divide किया. Now what I did a crossover. Chromosome 2 का B part को लेके chromosome 1 पे डाल दिया, और chromosome 1 का B part को लेके मैंने chromosome 2 में डाल दिया. So I got two offsprings. This is the simple method of crossover. This is the simple method of crossover. It is not that this is the only method of crossover. In some cases, see here, in some cases, I divide it into three parts, A, B, C parts. and then again I cross over and make two offsprings. Okay, so there are a 2-layer crossovers. Okay, so here this is a simple method of crossover so that it will be easy for you to understand. So now from two parent chromosomes, which are the binary string of two parent values, population value which you have found out, usme se now you have got two offsprings after the crossover. Okay, now with this crossover, I told you that we cannot say that it will give you a fit value. So as in the next layer, it is the mutation part. What we do is, as a means researcher, I go through this original offspring values and I find that A1 को 0 बनाया, A0 को 1 बनाया. See, just like that. See, I have written that. Mutation operation randomly changes the offspring resulted from the crossover and is intended to prevent falling of all solutions in the population into a local optimum of the problem. Many a time that is the main problem with all of these soft computing techniques. Local minimization में आ जाता है, whereas that is not the global minimum value. You will find that it is a lower value. यार पीछे हमने बोला है ना, the best value if it is a lower value or the best value is a higher value. We go for a higher value, but that may be the value of all the value, higher of all the value. So a local minimum में आके रुक जाता है. So to prevent that, what we do, we randomly change zeros and ones. That is why it is known as mutation. Simply change some bit into 0 and some bit into 1. You may ask me, ma'am, it is very difficult. Yes, it is very difficult. But we do it like that only. Usually what we do it, we give some random I means MATLAB की rand कमांड को यूज करके मैटलैब को ही हम दे देते हैं रैंड एंड इट चेंजेस. वो रैंड वैल्यू में जो 0 है उसको 1 बना देते हैं, 1 को 0 बना देते हैं, एंड देन वी अगेन डू द सेम प्रोसीजर. So here, and I've already shown you that. So these procedures one by one I have shown you. Now with research, these are simple, the most simple methods I have explained to you. Now you go into papers, there are various types of selection, various types of crossover, various types of mutation techniques you will find out, so that you can have these techniques also applied into it. These are the simple crossover and mutation techniques for your information, for enlightening your like your knowledge buds, so that you will ask me, you will think about it, you will learn more about it. That's the only means intention which I have done, because the time which Madam Poonam had given me, I could combine all this. These are all very vast areas of study, and I feel that you all should go into all this. Then only a real research techniques can be done. Now I'm not going into the details. I'll give you some more applications of these areas: control, design, scheduling, robotics, machine learning, signal processing, game playing, combinatorial optimization. Now I will give you some electrical engineering applications, because I am an electrical engineer. Electrical engineering, madam will give you more insight into all the areas of engineering: mechanical, mathematics, electrical ka bhi Professor Chatterjee will give you a lecture, but then I will give you a overview of some areas where these can be applied. One is the induction motor speed control. You will get so many papers in which it has already been, not only induction motors, DC motors, speed control of machines पे, all these are applied. आपको बहुत papers मिल जाएगा. Another area is power system, voltage instability prediction of in power system using neural network, fuzzy logic, neurofuzzy. All those areas are again well researched areas. You know, IEEE 14 bus test power system you will get, and on those power system using MATLAB, Simulink, coding, you can apply NN and fuzzy logic, neurofuzzy to find out the actual control or the voltage instability prediction. Okay, another area of optimization, fax controllers or local placement of fax controllers, optimum placement of fax controllers, optimum placement of other controllers also. So all these areas, these techniques, because you know neural network and fuzzy logic are very good control techniques, and GA or PSO and other evolutionary techniques, biologically inspired techniques are very good optimization techniques where you will get the optimum values. So all these are again other areas in which these can be working. Many either a genetic algorithm applications to find out the unit commitment problem of selecting generating units to be in service during a scheduling period. एक बड़ा पावर सिस्टम में कितने जनरेटिंग यूनिट्स शेड्यूल में डालना है, कितने जनरेटिंग यूनिट से जनरेट करना है, whereas 2 generating units can be shut down and do the repair of it or do the regular maintenance of it. So such a unit commitment problem also can be done by using genetic algorithm, by coding the variables, randomly selecting the variables, depending on the load of the system, कौन-कौन सा generating units को off करना है, on करना है, all those areas of research are available and people are using it also. And you know, in the coming days when smart grid is going to happen, so these are very much important, where you require these types of techniques in your system. Means artificially intelligent techniques has to be put into, so that your grid, power grid, becomes smart and intelligent. Okay. There are other important application also. Robot arms. In robots, motors are used, permanent magnet synchronous motors are used, which can be done by fuzzy neural network approach. There also speed control of induction motors are done because of robot की arm को movement को control करने के लिए these can be applied. So there are various applications where motors and power systems and electrical systems can be applied. These are again a very general type. I know the group are not only electrical engineers, so pattern recognition, air conditioners, washing machines, vacuum cleaners, anti-skid braking systems, transmission systems, control of subway systems, unmanned helicopters, knowledge-based systems for multi-objective optimization, weather forecasting, models for new product pricing, so medical diagnosis, treatment plans, stock trading, so many areas where these techniques can be used. It is not that these soft computing techniques are of computer science people. It can be utilized for all electrical engineers, mathematicians, mechanical engineers, civil engineers. So it is a common tool which it is very much utilized in research areas. Thank you so much. Any questions?